So this is our first lesson on Chapter 5, and we're going to look at solving inequalities here. Now we're going to link this in what we did in the previous chapter, and we're going to try and actually graph this. To begin with though, we're not going to worry about the greater than 0, we're just going to pretend it equals 0. So we've got a few different ways we can solve this. We could use the quadratic formula, complete and square, but certainly by far the easiest way to do this would be to factor. So if I factor this, remember what we can find from here is when this equals 0, I actually put less than here. This is supposed to be greater than to match up with this question, so let me quickly change that. We can find out the roots for this graph, so 4 and positive 2. And also with this being x squared, we can see the nice U shape on here. So if I was to use those 2 points and graph, then it would actually look like this. Now for our question here, we're looking when is it greater than 0. Now what that actually means is, when are the y values greater than 0? So you might want to make a note of this in your notes. When you're looking for greater than 0, or greater than or equal to 0, you're looking when is it above the x-axis. Now for this graph here, you can see that this is above the x-axis, and so is this point here. And I actually already have the shading done for this graph. So I have the shading, but I have the wrong equation. So I'm looking at this part here, and I'm looking at this part here. Now notice the x values for these points. If I look down here and here, these are all to the left of 2. So what I could say is x is less than 2. Now for all these points on this side, if I was to look at the x values, can you see that all these numbers are greater than 4? So I could put x is greater than 4. Now I'm not going to put equal to on this question because the question up here also doesn't have that. But if the question was to say greater than or equal to 0, I would do the same thing. I would factor, I would draw my graph, and then I would just add on the equal signs to those questions. Now the alternative is, what if it's less than 0? Well, same thing, I'm going to factor, I'm going to draw my graph. This time I'm going to say when are the y values less than 0, and what that actually means is when is it below the x-axis. So for this graph here, I'm looking at these 2 points and these points here. So let's see if I got this one right. There we go. And for those, you can see that all these values here, like 2.5, 3, 3.5, they're all between 2 and 4. So I can write myself a compound inequality straight away. It will always have what looks like less than for each ones, and you just say x is between whichever 2 numbers it actually is. So 2 and 4 for this case. If I was to make this less than or equal to, the only thing that changes on this would be that part there. So the key part about this question really is finding the zeros of the function, making a sketch of the graph, and then looking is it above the axis if we're talking about greater than or equal to, or below the graph if we're talking about less than or equal to. Now I've made this one a little bit more difficult. I've made this negative x squared, so we certainly know that's going to be an upside down parabola. I've included a greater than or equal to on this occasion. I'm going to try and find the zeros of this. I'm going to factor, but I'm going to take out this negative as a common factor first. So hopefully I get something that's a little simpler to factor. And then once I've done that, that's going to factor nice and easily for this. So my zeros for this would be -4 and +2. And because of the negative at the start of the question, I'm going to get that upside down parabola. So if I just go ahead and graph this now, then you can see this works quite nicely. Also, we can see that there's a y-intercept of 8, which looks quite possible for my graph as well. Now for this specific question, it asks when is it greater than 0, or greater than or equal to 0, which means I'm looking when is it above the x-axis. So I've already gone ahead and done the shading for this. It's certainly on these parts here. And what we notice is that for all these values, notice this graph continues as well. It's just off the top of my picture right now. So it's all these values between these 2 numbers. So once again, I wrote myself a little compound inequality. X is between -4 and 2. I included the equal sign because there was an equal sign within the question. Now if I do the reverse question, it's going to be very similar. This time, rather than being greater than, I would actually like to make it less than. So same thing, I've got my graph drawn. The only thing I'm looking for this time is when is it less than. So I'm really looking at the parts when is it below the x-axis. So in other words, here and here. So I notice that these values are to the left of negative 4, so I would say x is less than or equal to, because of the question, negative 4. But also we go to the right of 2. So x is greater than or equal to 2. So same idea whether we've got negative x squared or positive x squared. Draw the graph first, find out what those roots are, and then look, is it above the axis or below the axis, wherever is appropriate for that question. Now, as we looked at cubic equations in the previous section as well, I've had one question like that. So I went ahead and factored here, took x as a common factor, and then refactored. X cubed, I automatically know, is this shaped graph that you can see. Notice my zeros as well. So 0 is one of my intercepts, positive 4 is one of my intercepts, and negative 1 is one of my intercepts. Now for this question, it says, when is it greater than or equal to 0? So I'm looking above the axis, so I'm looking here, and I'm also looking here. So I've got two separate ones I need to write. This one here is to the right of 4, so that will be x is greater than or equal to 4, equal to because of the question. And these numbers here, it's between two numbers, it's between negative 1 and 0. So negative 1 is less than or equal to x, which is less than or equal to 0. And if you want to, you can also use the U notation as well, to show it's the union of those two answers together. Now, sometimes you're also asked to do this by a table of values, and I believe this is a common method for the AP as well. So if I was to do this question, x squared minus 6x plus 8, this certainly factors. So x minus 2, x minus 4. So you can see now where 2 and 4 comes from on this graph. So I've set up a table here with 5 values. I've put my first, smallest value in position 2, and my largest value in position 4, and I already know these equal 0, and you can see that from the graph. And then what I'm going to do is, I'm going to choose, let me just get a contrasting colour pen here. I have to choose a value to the left of 2. Now I'm going to choose 0 because that's a very nice value to choose. Perhaps I'm going to have to write this above because it doesn't seem to want to write it in there. So I'm going to choose 0. I have to choose a number between 2 and 4. So I'm going to go with 3. Always good if we can choose whole numbers and as small as possible. And I have to choose a number that's bigger than 4. So I'm going to go with 5. And then what we're going to do is we're going to substitute those numbers into the formula. Now you can either plug it directly into here or into the factored form, and you should still get the same answer. So 0 minus 2 is negative 2, 0 minus 4 is negative 4, so negative 2 times negative 4, positive 8. And ideally we'd like to put it here, and it won't let me do that for some reason right now. If I plug 3 into here, 3 minus 2 is 1, 3 minus 4 is negative 1, and then when we multiply those two answers together, we get negative 1. The last one I've got to do is 5, so 5 minus 2 is 3, 5 minus 4 is 1, and then 3 times 1 would give me positive 3. Now what we're looking for on the table is this part here. When is this greater than 0? So if I look to the left of 2, I can certainly see I've got a positive answer here. So that's actually one of my answers. X is less than 2. Now if I look between the two numbers, I can see this is not greater than 0, so I can actually ignore that part. And if I look to the right of 2, once again I can see I got an answer that's greater than 0, so also I can say anything that is greater than 4 would also work. Now obviously from this graph you can see that this is true anyway. X is less than 2, and x is greater than 4. If you are filling in that table, the numbers actually aren't that important. What's important is, are they positive or negative? So if you look at this part of the graph anyway, the positive x squared, you know that it's always going to start positive, go negative, and then go positive, which is exactly what you see here anyway. So you can sometimes use that as a shortcut as well to finding out that answer. What I had hidden under the slide was essentially what I asked you to find out when you're doing that table. Find a value to the left, find a value between, and find a value to the right.